Hello and welcome to coming to my session on chaos engineering for vSphere. My name is Daemon Behr. I am a VCP, DCV, VCP, NV, VCAP, and a vExpert. I'm going to jump right in and tell you what chaos engineering is, and then I'm going to show you some examples that you can use in a vSphere environment to utilize it. So what is chaos engineering? It's a means of experimentation. There's 4 principles in chaos engineering. The first one is to define what a normal behavior is, or what's a steady state. So that's based on things such as resource utilization, throughput, general load, that sort of thing. The second thing is you would hypothesize about the state behavior when an experimental group is compared to a stable group. So if you have an idea of how your environment is going to react under normal conditions, then you can take a subset of that, and then you can create an experimental group and then apply different scenarios over to that. So in the experimental group, what you would want to do is simulate certain types of real-world events over to it, whether it's a failure of certain aspects of it, or whether it's a certain load on the environment. And then the fourth thing is you test the hypothesis that you have against what actually happens in the real world, and then you see what the difference is. The closer to the hypothesis and the less impact to the environment, the more resilient and the more reliable your environment is. So to sum it up into easy terms, you intentionally break things, you compare what's measured versus what's expected, and then once you have a look at that, then you fix those problems and then you move on to the future. Now, a really good example of chaos engineering, which was popularized by Netflix, is the Chaos Monkey. Now, the Chaos Monkey was the first one to really become well known, and it allowed you to do fault injection and all sorts of different things. And there's actually a whole group of different types of utilities, which they call the simian army. Now, one problem with the Chaos Monkey when you're looking at a vSphere environment is that it doesn't allow you to hook directly into vSpheres. It's built for Amazon because that's what Netflix actually uses. So there was a fork off, there was a fork off of Chaos Monkey, which is called the Chaos Lemur. Now, the Chaos Lemur will allow you to hook into AWS as well as vSphere as well. So you can do a lot of similar things, and you can do a fault injection, you can fail VMs. There's a whole scripting language around it that you can really make use of. Now, that's not the only tool that you can use. You're also able to use power CLI scripts in order to cause certain things to fail. But the important thing is that when you have an environment like this set up, you can't just go and start breaking things and then look at it afterwards. You have to have a very, very sophisticated monitoring environment. So some tools that you can use to get detailed information on your environment are vRealize operations, Log Insight on the network side, vRealize Network Insight, and what was just announced recently at one of the keynotes here at VMworld is App Defense, which really lets you understand the associations and dependencies between the different VMs. I'm just going to back up one slide for a second. So one way that you can look at chaos engineering is how it's done in a similar environment, but on the security side. So if you were to compare penetration testing and chaos engineering, there's similarities and there's differences. So pen tests are basically for security what chaos engineering is for infrastructure. Pen tests exploit code vulnerabilities and configuration vulnerabilities. Chaos engineering exploits design vulnerabilities. Pen testing and red teaming, when they're done, it's usually done with the knowledge of a select few within the organization, whereas chaos engineering is much more open, and it tries to involve as many people as possible when you're actually doing it. So to drill down a bit more into the way that it looks, VMs can be targeted based on a group association. So just like with VMware, you can tag VMs, have different sorts of categories and groups. But VMs are comprised of an operating system component and services. But services aren't necessarily tied to specific VMs. Some applications have multiple services which span multiple VMs. So you can target services based on association with a group. So something that you want to do is create memberships and map them out based on the various groups. Then you create incident identifiers and you associate the probability of those incidents occurring. And then you action certain memberships and you do fault insertion against them. So if you have a certain type of application, you can see what is all the services that are associated with it, what are the different ways that it can fail, and then you can assign a probability to it. So when you're using a tool like Chaos Lemur, it allows you to take the memberships and then assign a probability to it, and then over a period of time, it will fail those different components based on the probability that you actually assign. So to look at how it would look like if you were starting from scratch and you want to build something up like this, this is the process that you would look at. You would want to list all the different VMs that you have in your environment, list all the services on all the VMs, then you list all the applications that you have in your environment, and then associate the services to the applications. And then you map out functional services versus feature services. If you were to look at an application and if parts of it can fail, but the rest of it, the core, is still working, then the parts that fail, that are non-critical, those are what are deemed as feature services. Core services or functional services are the things that are required in order to keep things running and moving along. Then you create a service dependency tree so that you can understand if something fails, how does that actually affect the other services that are associated with it. And then you create an application to functional services dependency tree, and then an application to feature service dependency tree. So once you have this holistic view, you can understand what parts of your environment can fail and what's associated to them, and then you can determine, based on the probability of different types of things that can fail, how it will actually affect your environment. Then you want to monitor all the VMs, services, and user-facing applications for performance. So understanding how an application is performing is critical to understanding how things get affected in your environment. If something is just running, then that's not necessarily a good view of how the end user sees it. Then you create an expectation disruption tree based on the known associations. So by understanding what is a dependency of what and what are the associations of what, you can determine what the end user of the applications or the rest of the infrastructure is actually going to experience. Then you would want to create a remediation plan for each type of the failure, whether it's the VMs or the service or compute or infrastructure. And then once you get an idea of that, then you can understand what the business impact is of those specific failures. And once you understand the business impact, what is the actual cost to the business, then you can measure that business impact against the service level objectives that you currently have in your environment, and how well do they actually match up and marry. And then what is the probability of each incident occurring? Once you understand the probability of a fault occurring, then you can determine how much effort you're actually going to put in to fix those issues or bolster those certain areas of the environment. So chaos engineering requires a certain level of, or base level of resilience. So you wouldn't necessarily want to do this in an environment that hasn't gone through standard recommended practices, or some people deem them as best practices. You want to know that things are operational, that if you fail one thing, it's not going to have catastrophic failure across the entire environment. And then you start planning the experiments, and then you determine what are you going to include in these different types of experiments. And then you compile a list of failure modes. How are things going to actually fail? And if this was a real incident, how would it occur? And then you map out how that would occur in your test environments. Then once you go through that process, you pick a date and you get all the stakeholders that are involved with a certain experiment that you want to do. And you ensure that there's going to be no impact to customers, that there's a way that you can do it without actually causing severe downtime to the environment. then you gather the entire team together, all the stakeholders, and you basically have a big screen up with your different monitoring dashboards, and then you start failing things out, and then you see how it actually reacts. And since all the stakeholders are there, they can take direct responsibility for these applications and the things that or the hypothesis that have been provided to ensure that those marry up. And this isn't something that is meant to use to point fingers or blames or so on. It's something that will allow the entire team to really work together and work together to build a more resilient system. So a lot of the topics that I'm talking about here around chaos engineering, I've actually included in a book that I've just launched over here at VMworld, which is the second book in the IT Architect series, which is called Designing Risk in IT Infrastructure. Now there's a number of other topics listed over there that I actually go through in the book. Now this book is part of a series. We currently have 3 books in the series called the IT Architect series. The first book is around design and infrastructure, and the core things that you need to do around building infrastructure, and it's very, very useful if you're on the path towards VCX certification. The second one is my book, Designing Risk in IT Infrastructure, and it's about expanding the horizons of the way that you actually look at an environment and approach design. The third book, which is called The Journey, is all the things that you need to be aware of when you're looking to advance your career, and the steps that you need to take to reach that next level of environment or next level in your career. There we go. So thank you very much. If you want to follow me on Twitter, you can reach me at Daemon Behr. Or if you want to get some more information about the book or some other things I blog about, go over to designingrisk.com. Thank you very much.